Hi, I'm Mary Valamides, and I'm going to go over the second grade, third 6 weeks curriculum preview with you for mathematics. The very first day of the third 6 weeks will be November 14th, and you'll be giving the Math CBA that day. Then we're going to finish Unit 3, covering geometry and fractions. So we're going to be finishing two-dimensional figures. We have 4 days to finish. Now with this particular concept, we're going to be using Module 14. And notice 2.8a says to create two-dimensional shapes based on given attributes, including number of sides and vertices. Creating a figure is more difficult than recognizing a figure, so the kids might need to draw pictures. They might use their alpha shapes, or marshmallows with toothpicks, pipe cleaners, or any other type of manipulative such as pattern blocks to create two-dimensional shapes. So alpha shapes are very good to use because they have regular figures and irregular figures, such as here we see a regular hexagon, and then further down you see an irregular hexagon, so the kids can use these figures to make new shapes. In Texas Go Math, there's a concentration on the number of sides to name a figure. It refers to all four-sided figures as being quadrilaterals. Now, in first grade, Text 1.6d, we covered rectangles, squares, special rectangles, and rhombi. Now, in second grade, we're going to also introduce these additional quadrilaterals of trapezoid and parallelograms. So these are some vocabulary terms you want to make sure you use with the kids as we're talking about these different shapes from 3 to 12 sides. Now in Module 14, we have 2.8c that says classify and sort polygons with 12 or fewer sides according to their attributes, including the number of sides and the number of vertices. So we're going to use formal geometric language to classify and sort these shapes, and notice that we're going to use the attributes of number of sides, whether the sides are curved or not curved, whether they're congruent sides, which basically will be saying whether the sides are the same length, the number of vertices that they have. Now, as adults, I'm going to also share with you some descriptions of these different shapes using types of angles and whether they have parallel and perpendicular lines as well. So here you see a circle. It's curved. We have no straight sides because it's curved. It's a closed figure. So to have a side, it's usually a straight side. So these are all curved figures when we talk about circles. Now triangles, on the other hand, we have 3 sides. We have 3 vertices, which is where the sides meet. They sometimes were called corners in the past. And these are all closed figures. There's not a side that isn't covered with a line. Then quadrilaterals, they have 4 sides for 4 vertices. We have 4 angles and they're closed. So you can see that there's another page as well where we go over all of these different 12-sided figures, up to 12-sided figures, so that the different attributes that the kids can learn these different ways to describe these shapes. Then 2.8d, we compose two-dimensional shapes and 3-dimensional solids with given properties or attributes. Here the kids are going to put shapes together to create other shapes. So if you look at the green hexagon, it's made with 6 triangles, and it created that yellow hexagon that we're familiar with. So the kids can use 3 triangles, and they can create a trapezoid as well, or 2 squares to create a rectangle. Now on 2.8e, the kids are going to decompose two-dimensional shapes, such as cutting out a square from a rectangle, dividing a shape in half, or partitioning a rectangle into identical triangles and identifying the resulting geometric parts. So here you see we have a rectangle, and then we can take that rectangle and just divide it in half diagonally to form 2 triangles. Now notice the triangles have to have the same amount of area. We can also take that same rectangle and instead divide it into 4 equal rectangles, or we can divide it into 3 equal rectangles, depending on how we fold it. Then we have 4 days to talk about 3-dimensional figures. Now in first grade we had 1.6c, so the kids are coming to you knowing 1.6c. But notice 1.6c, compare it to 2.8b. What is the difference between these two texts? Notice that they're using the same three-dimensional figures, and really the only difference is the verb. 1.6c, we were identifying three-dimensional solids, but 2.8b, we are classifying and sorting these three-dimensional solids. So how the kids sort these, which ones have a curved face, which one has 8 rectangular faces, 8 vertices, 12 edges, so they can sort by the attributes. 2.8d says to compose two-dimensional shapes and three-dimensional solids with given properties or attributes. So we're going to look at these figures and we're going to be able to sort them, compose different shapes as well. Now if you look in Module 15, Lesson 3, please don't teach that lesson because it talks about nets and that's not a concept that's taught in 2nd grade. So skip that lesson. But make sure to clear up a misconception that kids might have. Explain to them what those dotted lines, for example in this cube, what they represent. Those are the edges that we really don't see because they're covered by the faces that are in front of them. Then we'll have 8 days after we talk about shapes right before the winter break to talk about fractions. Now 2.3a says to partition objects into equal parts that name the parts including halves, fourths, and eighths. So we're only talking about halves, fourths, and eighths. The kids are not working with sets of objects, so we're not going to give them 4 objects and say what's half of those objects. We're working with a whole object. So they need to make sure they understand that the parts are the same size, even if they have difficulty drawing them to depict those equal parts. So the kids need to understand, number 1, that the fraction gets this name from the number of equal parts that there are. So if there's 4 equal parts, they're called fourths. If there's 2 equal parts, they're called halves. If there's 8 equal parts, they're called eighths. They also need to be able to count the fractions by its parts, such as 1/4, 2/4, 3/4, and 4/4, when they're trying to find out how many of parts there are. And they should also be able to understand that the only way that there's a whole is when you name all of its equal parts. So there should be 4/4 to equal a whole, 2 halves to equal a whole, or 8 eighths. One activity you can do with the kids is paper folding, so that you can have them fold with paper these different fractions. Or you can use number lines as well as labeling the equal parts of a rectangle in words and traditional fraction notation. So here's the folding activity with a paper. You can take a sheet of paper, fold it in half, and then open it up and make that crease. Have the kids use their pencil to draw that line for the crease. So you'll see that is the half is designated with the red color down here at the bottom. Then you'll take another piece of paper, fold it in half, and then fold it in half again. That will, when you open it up, you're going to have fourths. And have the kids again take their pencil and make those lines for on the creases to show fourths. And then take one more paper and fold it into eighths. So you're going to fold that in half, and then in half again, and then half one more time, and then open it up, and the kids will have those eighths. So then they can draw the lines with those creases, and then they can compare. Notice that the eighths have smaller parts than the fourths, and the fourths have smaller parts than the halves. So that leads us to 2.3b, where the kids are supposed to explain that the more fractional parts there are to use to make the whole, the smaller the part. And the fewer there are, such as halves, the larger the part. We also have 2.3c, where you use concrete models to count fractional parts beyond one whole. Yes, we go into mixed numbers in 2nd grade, but with tangible, really concrete models so the kids can see it and understand it. So here we have two squares. They're cut up in groups of 4. So the kids will count each fourth, 1/4, 2/4, 3/4, 4/4, until they come to 8/4. So they're supposed to say 8/4. It's an improper fraction. 2.3d says to identify examples and non-examples of halves, fourths, and eighths. Notice the examples are here, the 3. We have one square that has 4 squares. The second square has 4 rectangles. But notice the third square. We have 2 rectangles that have they're long rectangles, but then we have two squares. But all of these pieces have the same amount of area. So we can say that these are the same. These are fourths. But then we have non-examples of fourths that the kids also need to show. So you'll notice the non-examples do not have the same amount of area. So these are not truly fourths. Then after winter break, we're going to be subtracting two-digit numbers. So these will cover text 2.4b, where we add up to 4 two-digit numbers and subtract two-digit numbers using mental strategies and algorithms based on knowledge of place value and properties of operations. And then we'll also be solving one-step and multi-step word problems involving addition and subtraction within 1000 using a variety of strategies based on place value, including algorithms. So here when we're doing addition and subtraction, please bring out those base 10 blocks. You have connecting base 10 blocks in second grade, so that you can easily show regrouping with them, because you can snap them apart or connect them together for the units. So notice that whenever we're talking about base 10 blocks, there are a proportional relationship between the pieces. So let's give them the right names. If you see, the smallest pieces are called units. The piece that has 10 connected are called rods. The piece that stands for 100 are called flats. And then the cube has 1000 pieces, so you'll see this is called the cube. They represent these whole numbers in second grade. Now for the second 6 weeks, we talked about addition. So we had this graphic that we use for addition, and such as for 15 plus 23, notice we had the 5 ones, and then we had the 10 on this graphic organizer, and that just to show 15. Then in our graphic on the side, we showed that we had 5 ones and 1 10 for 15. And then when we added 23 to it, we added 2 rods and 3 units with our manipulatives on this side of the graphic organizer. But then over here we have our 2 and our 3. So we have 3 ones and 2 10s. When we add them together, we'll notice that we have 3 10s and 8 ones. So when we add them over here with our algorithm, we'll see that 5 plus 3 does equal 8, and 1 plus 2 does equal 3. So that's really not just 3, it's 30. So we're saying 10 plus 20 is equal to 30. So altogether, it's 38. If we have 24 plus 36, notice now we're going to bring in regrouping. We show first the 24 with our base 10 blocks. And we'll show it on our graphic organizer as well, that we have 20 plus 4, so therefore we have 2 10s and 4 1s. And then we add 36 to it. But now that we have 36, we have our 3 10s and our 6 1s, and notice that this whole section now is full. When it's full, then it's time to go ahead and regroup. So when we say 4 plus 6, we know that's 10. But what does that actually mean? It means that rod is going to go over, those units are now together, and it's going to go over and add and join the 10s. So 4 plus 6 will be a 10, and notice that 1 is really supposed to be over here on top of the 2, so that we have 10 plus 20 plus 30 equals 60. So if we describe this result in words and numbers, we showed it in numbers, but the kids need to be able to explain that we have 10 plus 20 plus 30, which equals 60. So we have 6 10s and 0 1s, 60 plus 0 or 60. If we have 24 plus 38, the 10 does go over, but notice we have 2 left over, and that 10 just falls down to the bottom, so that we can show that 24 plus 38, 4 plus 8 is 12. We can see it with the 2 in the 1's place and the 10 in the 10's place that went over and joined the 10s in our getting on our flat. But if you notice here, we had the 2 left over, so we have our 2 here, and we're adding 10 plus 20 plus 30, and we have 60. So altogether, we have 62. In the third 6 weeks, we're going to talk about subtraction. The reason why I wanted to show you that addition is because we're using basically the same graphic organizer for this to do subtraction as well. So with subtraction, we're going to start with our 62, our minuend, and we're going to subtract the subtrahend 34. So 62 minus 34. So we can first cross out our 6 because we're going to take from that 6 a 10. So now that 6 becomes a 5. Notice on our graphic organizer on the right. And our 2 now becomes a 12. So when we look at our organizer, that 10 is going to come over and join the units. So that now we do have 12. So we have 5 tens. And you can see the 5 tens over here on the left, as well as on our little graphic organizer on the right. And yet we have 12 ones. You can see that over here as well. So our 62 has now become, our 60 plus 2 has become 50 plus 12. Then the next step is we're going to take away 4 from that 12. So now 12 minus 4 leaves 8. And notice that we did have 4 disappear. So 12 minus 4 equals 8. Now we look at what's left on our left-hand side where we have 50, but now we need to take 30 away from that 50 because we have a 34. And when we take that away, 5 minus 3 is 2, or we can say 50 minus 30 is 20. So we have 20 plus 8, that leaves us with 28. So 62 minus 34 equals 28. So when we're talking about these terms, do we use the term carry and borrow? No. We use the terms regroup and rename. So when we're looking at carry and borrow, these are just mechanical manipulation of symbols. So we're not going to use those terms. That's a little misleading. But we're going to use the term regroup because that's appropriate when using manipulatives like we just did for a quantity that's grouped differently. And rename. Rename is mathematically correct because it's talking about a quantity that's actually given a different name. So when we had earlier those, I think it was 24 minus 38, 62 minus 34. We regrouped 62 into 5 tens and 12 ones to solve this problem. So that would be regrouping. And we renamed it as well. Now, properties of operations, commutative property of addition. It doesn't matter if you say 64 plus 27 or 27 plus 64, the answer is going to be the same. Also, the identity property of addition. Anything plus 0 is that number, that original number. The associative property of addition also is the grouping of the addends. It doesn't make a difference when you're adding. Now, of course, it does make a difference when we add the other operations, but with addition, it doesn't make a difference which two numbers you add first. So you can always, it allows you to put compatible add-ins together. So such as 64 plus 57 plus 16, you'll probably want to put 64 plus 16 together because you can see that 4 plus 6 is 10. So that would be an easier way to add these numbers than to add 64 plus 57 plus 16. So strategies to use to model subtraction. Notice please make sure you're using the proper vocabulary with the kids. And then when you're doing subtraction, please use your number lines. You can, if you have 37 minus 16, you can start at 37. And notice that we're going to jump 10 spaces to the left for 20, and then to 27, which is a multiple of a 10. These are benchmark numbers. And then to 17. And then you're going to make another jump to the left, so that to 16, and you can label the spaces that were jumped. So 37 minus 16, here we'll have 21, because 10 plus 10 plus 1 is 21. You can also do 2-digit subtraction using a number line. Or you could use the break apart method. Here we have 44 as our minuend minus 16 our subtrahend. You could take 16 and break it apart into 10 plus 6, and then you could take 6 and break it apart even further into 4 plus 2. So that when we do this, now when we have 44, we can jump to 34, and that takes care of our 10. we can jump to 30, which would be minus 4, and then we can jump to 2, which would be 28. So 44 minus 16 is 28. Now the reason we broke 6 into 4 plus 2 is because we landed on 34 and we needed only 4 more to get to 30. So it was more convenient to break apart 6 to 4 plus 2 instead of 5 plus 1 or 0 plus 6. You can also use the break apart strategy in this way, where you make 61 into 50 plus 11 and 27 into 20 plus 7. So that now we can say 50 minus 20 is 30 and 11 minus 7 is 4. So the answer would be 34. Please check to make sure you received the UPS check poster. I'd like for you to have those in the front of your room where kids can look at them and use them to solve problems. You should have also received your strategies poster so that the kids can refer to them. If they get stuck, you can tell them, look at that strategy poster. Is there a strategy that can help you solve this problem? So it can give them some ideas of what they can do, some place to start. Now also when you go into Eduphoria, you're going to see that I've made these little cards that you can put in journals, or you can put them on their desk, on the student's desk. These are little questions that it can prompt the kids to go to that next step. So they can ask these questions to themselves as they're doing the task of solving the problem. There's also some cards that the kids can use to interview each other when they're checking each other's work. I've also updated this form that says what teachers and students say and do with UPS Check. These additional resources are available at Forethought. If you go to Yearly Content Documents and then District Instructional Resources and then click UPSC, then you'll see at the bottom there's a gear. If you click that, you'll see all these different attachments open up at the bottom. So also you'll see that there's a video available that you can watch as well. So please go to Eduphoria and access these new documents for you. If you'll look also the vocabulary, there's a lot of vocabulary for second grade with all these different geometric terms as well as fractional terms. So you'll see that some of these words in purple, the words that are in purple, the kids should be familiar with. However, we have 3 columns of words that kids may not be familiar with. So these are the terms that you want to concentrate on with your word wall and when you're talking about these concepts. It would be great if you can put them by concept so that you'll have the words for fractions separated in their own area from the words with the 2-dimensional and 3-dimensional terms. Here are some activities you can do with the kids. I say play because to me, when we're doing word walls, you can make it fun and make it seem like you're playing when they're actually learning. So if you do this vocabulary activity about baseball, it's a great time for this activity since we're in the midst of World Series. But you might want to play this activity. You can have the kids do charades or play hot seat. Now these activities are available. The PowerPoint you'll see is available to you, so you can just go to the end of the PowerPoint to get these activities. Thank you so much for listening to the curriculum preview. My name is Mary Vallamese. Please contact me if you have any questions. Have a great day. Bye.